Hello everyone, welcome back to the lecture 2 in our series Building Large Language Model from the Ground Up. In our previous section, we have explored what this series is all about and how by the end you will have a deep understanding of how powerful AI systems like ChatGPT, Gemini and Claude are actually built, not just how to use them. My name is Akbar Arif, and my goal with this series is simple to make the core concept of AI, LLMs easy, intuitive, and accessible to everyone who dreams of building intelligent systems. Today, we are going to dive into six major ideas that will shape your understanding of LLMs. The first one is what is large language model, of course, and the second is like what does large actually means in the LLM. The third topic is how are modern LLMs different from old school NLP models, and the fourth one is what the secret ingredient behind the LLM brilliance. Well, that's transform architecture. And the fifth one is like understanding confusing term, uh, AIML, DL, LLMs, and generative AI. LLMs and generative AI are somewhat similar but different. And in the sixth part, we will be discussing the real world application of LLMs that are transforming industries. So let's just get onto our first topic. So at first we have this what does large language actually means. Uh, let's just read the text over here. And LLM, a large language model, is a neural network designed to understand, generate, and respond to human-like text. These models are deep neural networks trained on massive amount of text data, sometimes encompassing large portion of the entire publicly available text on the internet. So if you have ever used ChatGPT, Cloud, or Gemini, you have already experienced an LLM in the action. Even if you didn't realize what is happening behind the scene, at its simplest, a large language model is a type of deep neural network that designed to do about three things that I understand. Like it understand human language, it generates meaningful responses, like it interact conversationally with us, almost like a human. So imagine feeding a machine massive amount of text, book, article, conversation, code, and more, and training it to predict what comes next in a sentence. That's the core of what LLM does. In essence, it's like teaching a machine how to think in words. When you ask like ChatGPT, plan me a relaxing day, and it responds with a detailed plan including yoga, breakfast, reading, and nature walk. It's not magic, it's a neural network predicting the most appropriate human like response based on the patterns it has learned. So, in short, an LLM is a deep neural network that trains on a vast amount of text data to understand and generate human like text. So, let's just get on the second topic for today. What does the large actually means in LLM? So, the large doesn't just describe the physical size of the model file. It represents something much deeper, the number of parameters the model has. So, basically, the large language model doesn't refer to the size of the file. It refers to the number of the parameters. Think parameters as a brain cell or knobs that controls how a model learns and represent knowledge. The more parameters a model have, the more complex pattern it can actually generate or understand. For example, we have here ChatGPT 2 has 1.5 billion parameters. GPT-3 has about 175 billion parameters. There are some model of GPT-3 as well that has about 378 billion parameters as well. So ChatGPT 4 has about 1.2 trillion parameters, and GPT-5 has about 5 to 10 trillion parameters. So what are the parameters? Like you can think parameter as a knowledge, it's a knowledgeable neuron or adjustable switches inside the model that shows what it learns from the data. Every time the model reads billions of sentences during the training, it adjusts these parameters slightly to learn relationships between the word meaning and the context. So, you know, if there will be a more number of parameters in the model, the more complex language pattern it can recognize, and the deeper its understanding of grammar, reasoning, and context become. And the last more, like it will be like giving us a response like more human like. As you can see over here, this ChatGPT 2 has 1.5 billion as a parameter. So it is an early example of coherent text generation. It will like just only generate you the text. GPT-3 has some like large number of parameters as compared to GPT-2, 175 billion. Major, like it's a major leap in reasoning and creativity. 175 billion parameters can actually generate the reasoning things, like it will think about that the answer is right or not, and it will be more creative. GPT-4 has approximately 1.1 to 2 trillions, so it can behave as a multimodal as well. It can generate text plus images. So that was a first multimodal that was introduced. And there comes the ChatGPT 5, estimated like have 5 to 10 trillion parameters. Like it's even deeper in contextual understanding, like it's more better in the reasoning part, you can say that, because of the like it has so much of the parameters. It is like really good in like reasoning part. And of course like it will understand the long term dependencies as well. So here's one chart I want to show you. Like right now the top models are these one. I have taken a screenshot of about 10 LLMs. So number one is ChatGPT 5. That's by OpenAI. And right now we don't know the parameters of GPT-5, as GPT-5 is not open source. But this Quinn 3 over here is open source, so they have released their number of the parameters. As you can see, like estimation of GPT-5 parameters was like about 5 to 10 trillions, right? But Quinn 3 Quinn 3 just have 235 billion parameters, which is like a lot lesser. And even after that, Quinn 3 is on the top 5 right now. So you can think that how much good Quinn 3 model is. Basically I think so Quinn 3 is using some different kind of architecture that is also open source. Basically they are using MOE, and they have introduced their own attention mechanism. Well, attention mechanism I will teach you afterwards in this series, so no need to worry about that. So we will be having this Llama 4 Scout over here. That's also an open source by the Meta AI. And see the leap over here. Like it is 235 billion and this is 17 billion. It's a lot like it has like very less number of parameters. And still Llama 4 was in top 10 uh, right now. And I think so like this model also have like Llama 4 also uses the architecture which includes MOE, the mixture of experts. And they have introduced there some thing called new attention mechanism they have introduced. So we will be like building these two model as well from the like ground up in the series afterwards. So let's just get on our third topic, which is how modern LLMs different from the old school NLP models. So like before large language model arrived, the field of natural language processing one works very differently. Earlier NLP system were rule based or task specific, which makes them rigid, limited, and difficult to scale. uh, like before the LLMs era, NLP model were like task specific. We have one model for translation, another for sentiment analysis, and another for summarization. Each had to be like trained separately with limited data. Then we come here with the LLM revolution. Now a single model can perform all the tasks and more even without being explicitly programmed like differently. For instance, you can ask ChatGPT to translate French paragraphs into the English, write a business email, create a poem, or generate Python codes, and it handle all seamlessly with the same with the same architecture, with the same trained model. So that's flexibility, being able to generalize across multiple language tasks, and is what separates LLMs from early NLP systems. Like old NLP was narrower, and LLMs are universal. You can say that. So let's just see what. Let's just get deep into like old school NLPs. They were like rule based and narrow. Let's just read the theory over here. In the early days of NLP, systems were built using handcrafted rules from the statistical method. Linguists and engineers manual design, grammar rules, word dictionaries, and logic based templates. The model could only understand specific patterns. It was explicitly taught. When language become ambiguous or creative, it failed. Of course, it's not LLM. For example, a sentiment analysis model could identify, I love this product as positive, but might completely misinterpret this movie isn't bad at all. A positive phrase with the negative word. So yeah, that's something NLP fails in. A translation system might rely on fixed phrase mapping instead of understanding meanings. A spam detector might just look for the keywords like free or win, missing the deeper context of the like messages. So traditional NLP works like a set of isolated island. Each island handled one task but couldn't help the others. And here that comes with the LLMs, model LLMs. Like it's unified, contextual, and intelligent. The came of Then came like large language model built using the transform architecture and trained on a massive amount of text from internet, books, and the codes. Unlike traditional NLP system, modern LLMs are general purpose. They can perform many tasks without being retrained for each one. For example, the same LLM can perform translation between the languages, summarize a research paper, write an email, generate codes, explain a concept. Like you can go copy paste your like theory, and like ChatGPT will make you understand those with the help of the example as well. So or even it will be like analyzing the emotions in the paragraph, all using the like same underlying model, because because it's understand context, not just keywords. Okay. So here's some features about old NLPs and modern LLMs. So you can just read it. I've mentioned all the things over here. So it's just for the short summary. I will be providing you this notes as well, so don't worry about that. So let's just get on our fourth topic. What's the secret ingredient behind the LLM's brilliance? So the magical ingredient is a transform architecture introduced in 2017 by Google researcher in the paper "Attention is All You Need." Well, that's the best research paper like for AI researchers. After this research paper, AI world actually changed. So before this model process text sequentially word by word, making them slow, bad at remembering long sentences. So transformer mainly introduced a concept of self attention, which allows a model to like look at the like all word in a sentence at once, understanding relation between the words, even if they are like far apart, and focusing on the most relevant part of the text. You can say that. So for example, in the sentence, the cat chases the dog because it was playful. The model can figure out that it refers to the cat, not the dog. So thanks to the attention mechanism, of course. But these days, the newer LLMs have different kind of attention mechanism. So we will be like discussing all the mechanism that are coming day by day, but in the future in the series. So this architecture is like the transform architecture power the chat GPT, like the GPT model, BERT, Gemini, Llama, and almost every major LLMs today. Like the transform block is the backbone of each and every LLMs. Like we are like right now we are just making changes in the transformer architecture. So these days what people has done in the transformer architecture is like they have changed one, like they have changed many part of the LLMs, but they have majorly changed the feed forward network part. They have like replaced the feed forward network by the MOE, mixture of experts. Well, I will be teaching you mixture of expert further in the series, so don't worry about that. So the transformer is like the secret ingredient behind the large language model. So let's just come on our fifth topic, which is understanding the confusing term like AI, ML, DL, LLM, and generative AI. As in this chart, like in this diagram, you can see that it's clearly mentioned that large language models comes under these all things. So let me just read the text. Deep neural networks for parsing and generating human like text. So large language just only generates the text, and the some part of it comes under the generative AI. As because we are generating the text, but generative AI is something different. Like it generates text, images, videos, and audios as well. Here you can see the definition. Generative AI involves the use of deep neural networks to create new content such as text, images, or various form of medias. So let's just see the definition of deep learning as well. Machine learning with neural networks consisting of many layers. So yeah, you can say that deep learning has introduced the neural network, deep neural network things into the machine learning. So the name came out to be like deep learning because they were using deep neural networks. And there's a machine learning algorithm that learns rules automatically from data. That's a simple definition. Of course, you all guys have known about this earlier. And the whole things come with the like artificial intelligence system, like system with the human like intelligence. So basically, what the difference is like as like in like hierarchical depiction of relationship between the different fields suggested like LLMs represent a specific application of deep learning techniques leveraging their abilities to process and generate human like text. Deep learning like is a specialized branch of machine learning that focus on using multi-layer neural networks, and machine learning and deep learning are the fields aimed to like implement algorithms that are unable to like enables computer to learn from the data and perform tasks that typically requires human intelligence. So I've also read the theory about this. Well, I think so I've put some theories that are more understandable in this lecture. So like you all can just go through this theory, and you will be able to understand it like quite well. It is like simple English, not it's not heavy one. And like it's most simple, you can say that. So let's just see our last topic for today, the real world application of LLM that are transforming industries. LLMs are like changing how we work, learn, communicate across the industries. Here are some major use cases. Like LLMs are like these days are being used in every fields. You can like do the language translation. You can ask ChatGPT about some thing more informative. Like it's really helpful in the medical field as well, and for the education, like it is like super awesome. We can take the help while coding. Like these are some example in which LMs are helping. First is like business and customer services, content creation. Like of course I've created some of my content from the chat gpt as well in this lecture. So like I'm not denying it that I haven't used the chat gpt, but I have used it. And in the education purposes, software development, the translation and the communication, healthcare, research and knowledge. So basically, in short, you can say that LLMs are no longer just a chatbot; they are becoming thinking partner across nearly every field. So let's end our lecture over here, and we will meet in the next lecture, where I will be teaching you about the transformer architecture. And yes, let's see you in the lecture 3, and please like, share, and subscribe. We'll be meeting you in the next lecture. Well, thank you. Bye.